Welcome to my channel everybody. This is the chapter of complex number. Now here I introduce a floating problem and see, and here is most of the problem I use here Newton's law of complex number. And now the question number 14, see, this is the equation x to the power 12 minus x to the power 11 plus x to the power 10 minus x to the power 9 dot and minus x plus 1 equal to 0. And now here multiply with the factor x plus 1 equal to 0, then you get here x to the power 13 plus 1 equal to 0 and solve from that, and this is 13 is equal to minus 1 and that would be minus 1 whole to the power 1 by 13. You know, as the power is a fraction, that is 1 by 13, so we have we get here the 13th solution. Okay, so in place of minus 1 and see, and that is equal to minus 1. This is cos pi, this is a cos pi plus I sin pi. As we get here the 13th solution, so if we get more more than one solution to a equation, then we when we get here a fraction, so in place of this angle we added a part, that is 2k pi. Okay, that is we added the number 2k pi plus pi here, then the number are multiplied by this, it means this is 1 by 13, and also sine, this is 2k pi plus pi by 13 here. Okay, so where k is equal to 0, 1, 2, 3 dot to 12. Okay, then you get the 30 solution. But if k equal to 0, then we get here k equal to 0. So then we get here if k equal to 0, this is pi by 13. Okay, no. If k is equal to 12, if k is equal to 12, then x is equal to cos 24 plus 25. No. That is here 6. 6 to the 12 and 13 by 13. Okay. If k is equal to 6, then cos 12 pi plus pi by 13 plus I into sine 12 pi plus pi by 13, then is equal to cos pi plus I sin pi. So this is x equal to minus 1, so x plus 1 equal to 0. So this is a factor which I have multiplied to the both sides. So for k equal to 6 is not valid for this equation, as this is your simplification factor. Okay, so the solution is, so the solution is a solution R when k is equal to 0, 1, 2, 3, 4, 5, 7, 8, 9, 10, 11 and 12. Okay, but 6 does not satisfy this equation. Okay, and I think all of you have better understood why k is not valid when 6. Okay, see carefully. And next question is Next question is this. 13. If 1 plus x whole to the power n is equal to a naught a1x plus a2x square plus dot dot an plus an x to the power n, given that n is a positive integer. So now we have to show the a naught a4 a8. Okay, the addition of that is equal to 2 to the power n minus 2 plus 2 to the power n by 2 minus 1 into cos of n pi by 4. And now here we have to put here first complex number, that is I, then here 1 plus I here, this is to the power n, this is a naught a1i, this is a2, but in case of a3, that is I square, this is here minus, this is here minus, I square means minus 1. And for the I to the power q, in place of x we put I, then I to the power q, this is I square into I, so minus I. So this is here minus I, a3. And in case of I to the power 4, that is minus 1 whole square, so plus. That is here a4 plus. In case of 5, that is I to the power 4 into I. So that is equal to only I into a5. And case of 6, that is I to the power 6, I square, and they are the product of 3 minus 1, so minus a6. Okay, we go to the up to 8. Okay, then here I to the power 7, and that is I to the power square whole to the power q, this is minus 1 into I. So minus a7 into I. In case of I to the power 8, and that is plus. Okay, again plus, we get here plus a8. Okay, now see here, compare with the real and imaginary. So we separated real and imaginary here. Okay. And common a1, a3, a5, a7. Okay, compare with this, and on the left hand side we have find on the left hand side here is root 2 to the power n, and 1 by root 2 plus I into 1 by root 2 to the power n. So we can express as a that is 2 to the power n by 2. Okay, and it will be pi by 4 plus I into sine pi by 4 here. And this is a naught, a2, a4, a6, a8, and plus I into of that. Okay, so see, for the n positive integer. So in case of previous problem, that is the 14 problem, see there is the power is the fraction, that is 1 by 13. So in case of fraction, this is 1 by 13, that is 13 number, 1 by 13. So there was a 13 solution, but here is an integer. In case of integer, so this is the another thing. So that's why n can be easily multiplied by this is not a fraction, so we can write here n pi by 4 plus I into 2 to the power n by 2 into cos n pi by 4. Okay, so a naught, a2, a4, a6, a8. Okay, so this is I into. Okay, so from that we can write here a naught, a2, a4, a6, and a8. And this is equal to 2 to the power n by 2 into cos n pi by 4 here. See, this is at a0, a4, a8. Okay, they are the 4 gap. So a2, a6 are absent here. So in that case, now if we put here 1, putting, let us assume this is a 1. Okay, putting here in place of x in I. Okay, putting here x is equal to 1, then 1, 2, equation 1. Okay. So this is your 2 to the power n. So a0, a1, a2, a3, a4, a5, a6, a7. Okay. And again putting x is equal to minus 1. Then 0 to the power n. a0 minus a1 plus a2 minus a3 plus a4 minus a5 plus a6 minus a7 plus a8. Okay. So this is the numbering, and we get here this is 2, this is 3, and this is 4. Okay. Adding 3 and 4. Then 2 to the power n plus 0. This is 2 times of a0, a2, a4, a6, a8. Okay. Therefore a0, a2, a4, a6, a8. This is 2 to the power n minus 1 divided by 2. We get here 5. From that, from 5 and 2, if we added these 2, then we get the required condition. See, now adding 5 and 2. This is how we get these are 2a0. These are cancelled. This is 2 into a4. 6 is a cancelled. 2 into a8. And this is a 2 to the power n by 2. N pi by 4. And this is how we get 2 to the power n minus 1. And divided by 2. Then we get the answer a0, a4, a8. And this is equal to divided by this. This is 2 to the power, this divided by 2. This is 2 to the power n by 2 minus 1. N pi by 4, 2 to the power n minus 2. Okay? Truth. In case of solving the 13th problem, see the 10 is also complete here. So here is 1 plus x to the power n, a0, a1, x, a2, x square like this, dot 2 there. So you have to show a0, a minus a2, a4 minus this is this, and a1 minus a3 plus a5 is this. Okay. So this is the step here, and a0, a2, a4 like this plus you can write here that is a0, a2. This is here. This is a a1. This is here a1 minus a3 plus a5. Okay, dot. So there is some selenium. This is their sign. So you wrongly written here cos. This is their cos. This is would be sign here. Okay. So we can easily write here. This is the solution for 10, and this is 10, and we can write also, and this is a1 minus a3 minus a5, and this is equal to 2 to the power n by 2 and sine n pi by 4. Okay. So question number 10 is also complete. Okay. See. Now I have to proceed to question number 12. Now find the real factor of x to the 6 plus 1. Real factor of x to the 6 plus 1, that is 12. Okay. So x to the 6 plus 1. So finding this factor we is the complex number of this chapter. So you take a 0, then you get here x to the power 6 is equal to minus 1, then again x is equal to minus 1 whole to the power 6, 1 by 6. So from this theorem, so we can write here cos pi. So this is a cos pi plus I sin pi to the power 1 by 6. As this is a fraction, so we can add it with the angle pi. With pi, this is 2k pi. So added 2k pi with pi here. Okay, and then 1 by 6. We can write here 1 by 6 into that is by 6. So I into sine. This is 2k pi plus pi, and this is there by 6, where k means 0, 1, 2, 3, 4, 5, 5. Okay, this is the solution which we get here. So now when k is equal to 0, so then x is equal to, that is cos pi by 6 plus I sin pi by 6. Okay, and this is a cos pi by 6, and that is equal to cos 30. This is root 3 by 2 here, plus I into, this is I into sin 30, that is half. K equal to when 1, then you get here x is equal to, this is here cos 1. This is, if we put here 1, then 3 pi by 6, that is pi by 2, plus I sin pi by 2 here. So pi sin pi by 2 is means here this is 0 and this is I here. When k is equal to 2, then x is equal to, if we put here 2 means 4 4 2 to the 4 plus 1 5. This is 5 pi by 6. This is cos 5 pi by 6 plus I sin 5 pi by 6 here, and that is cos pi minus pi by 6 plus I sin, this is here pi minus pi by 6. So this is minus cos pi by 6 and I into sin pi by 6, and pi by 6 means cos pi by 6 cos 30, and this is equal to cos 30 means this is root 3 by 2 here. Okay, root 3 by 2 plus I half. Okay, I into half. When k is equal to 3, then x is equal to 3, then 3 to the 6 plus 1, 3 to the 6 plus 1, 7. Okay, 6 plus 1, 7. So 7 pi by 2, pi by 6. So 7 means 6 by 6, then we get here pi plus pi by 6. Okay, I into sin pi plus pi by 6 here. Okay, so you can write here this is equal to this is pi. This is still on the tangent. Okay, so this is the tangent. So minus cos pi by 6 minus cos pi by 6. This is minus root 3 by 2. These also are with the third cell. So this is also minus half. When k is equal to 4, then x is equal to, when k equal to 4, 8. 4 to the 8 plus 1, 9. So 9, this is 9 pi by 6. 3 are cancelled, so 3 pi by 2. So this is 3 pi by 2. 3 pi by 2 means pi plus pi by 2. This is I into sin pi plus pi by 2, and this is equal to, and again go to the cell number 10. Okay, this is this way it's minus cos pi by 2. This is 3 into 19. Okay, minus cos pi by 2. Okay, plus minus I into 1, 90, cos sin 90 is 1. So this is a minus I. So again k equal to 5. then we get here, I guess up to 5. So 5 to 13, 10 plus 1, 11. 11, then 11 pi by 6. We can write here 12 pi minus pi, that is 11 pi. So 12 by this, so 2 pi minus pi by 6 here, I into sine 2 pi minus pi by 6 here, and that is equal to, this is 2 pi. 2 pi means this is a cell of cos, so cos is cos pi by 6 here. So cos pi by 6 minus, and go to the same cos, so that's why sine is negative here. That is I into sine pi by 6 here. So pi by 6 means root 3 by 2. Okay, cos pi by 6 means 30, root 3 by 2 here. So I into half. And now the factor. Now we have to find the factor. So that is, you can write here x to 6 plus 1 is equal to, and this is here x equal to this, so we can write here x minus root 3 by 2 minus I into half. And compared like that, the factor is here, is this. So we have taken 0 and 5. These two factors are taken here. So x minus root 3 by 2 and plus I by half. And taken x equal to, k for k equal to 1 is I. So x minus I. So then we take a x equal to 4 for that, so x plus I here. And again into, again the other 2. If we take 2, then we get the factor here x plus root 3 by 2, and this is shifted to the right left hand, so this. And for 3, we get here this, okay, x plus root 3 by 2 plus I into half. So if we multiply these as this, so a plus b minus this, we get here, and this is whole square plus 1 by 4. Okay, if we multiply these two, then x square plus 1. If we multiply these two, okay, here x plus root 3 by 2 whole square, so plus 1 by 4. Okay, see carefully, this is a 3 factor, okay. So it also can be simplified by like that, okay. Now x square 2ab, this is root 3x, and that is 3 by 4 plus 1, this is 1 here. If we multiply, simplify this factor, we get here x square, and this here root 3x, and this is 3 by 4 and 1 by 4, this is 1 here. Another factor will be x square plus 1. So these 3 factor, real factor. And in the question they were given that to find the real factor. And this was the this is the all our complex factor, but if you multiply that, then you get the 3 real factor, okay? So you all are better understood for this problem, okay? Now we have to proceed the question number 11. And for the question number 11, and same type of question we have to discuss the same problem on my YouTube channel. There's the same problem. Now see, again we have to solve this problem so that the equation this a square cos square theta, b square sin square theta, and 2ga cos theta, 2ab sin theta plus c equal to 0 has a 4 roots, and sum of the roots is an even multiple of pi radian. And this type of problem actually you have to use there the expansion of tan, okay. So in my some video there was a discussion about the tan expansion, okay, and after that this type of problem I have solved and introduced my YouTube video. Okay, now see again I have to solve this, okay, see. So this is at 11. Now a square cos square theta and b square, and this problem, this type of question which I introduced with you, all of you, and this is the most important formula for the IIT and more other competitive exam. Okay, and also this problem are related with the B.Sc exams and B.Tech. Okay, so see, okay, see, and this is a b square sin square theta, b square sin square theta plus 2ga into cos theta. Okay, into cos theta plus 2ab into sine theta plus c. So now use the formula of multiple angle, that is cos theta. This is 1 minus, we can write here, theta by 2 by 1 plus tan square theta by 2. We have to use the 1 minus t square by 1 plus t square. Again sine theta, and that is equal to 2 sine theta, and this is a 2 tan theta by 2 by 1 plus tan square theta by 2, and that is equal to 2t by, okay, let t is equal to tan theta by 8. And with this expansion, we substitute the influence of cos theta is this, sin theta is this, okay. Now what I can see here, so a square, and this is cos square, that is 1 minus and t square by 1 plus t square, and this is whole square. And also actually I want to total equation is expressed as some variable and subject to sum, but here you see sine cos, and these two type of variation of this problem to solving this, and follow the question here. So like that. So this is in term of tan c, this is also a term of t, and this whole thing is in term of t. So substitute here, see the simplification. This is sine, this is 2t by, okay, 2ga cos theta. Cos theta means 1 minus t square by 1 plus t square, 2ab sin theta, and that would be 2t by 1 plus t square plus, and this is equal to 0. Okay, plus c is equal to 0. And take a LCM of 1 plus t square whole to the power 4 here, okay, and take a LCM, then we have to get that, and this is a square into 1 plus t square whole square, this is b square into 2t, this is b square into, or this is a square, so this is a 4t square, this is 2ga, this is 2ga, and this is 1 minus t square and 1 plus t square, okay. And now see 2ab, 2t into 1 plus t square, okay, c into 1 plus t square whole square equal to 0. Okay, now expand this. So a square, and this is here 1 and t to the power 4 minus 2t square plus 1. Again 4b square and t square. We multiply this. If we multiply this, we get here 2ga and 1 minus t square. Again, if we multiply this, 2ab, 4ab, and multiply by t plus t cube, and expand this c, t to the power 4 plus 2t square plus 1. Okay, and this is the biquadratic equation for t variable, and c, if we take account t to the power 4, what happened? This is a square, okay, and here is t to the power, this is t to the power square, and now this is here plus c, okay, this is here to the power 4, so c minus 2ga into t to the power 4. C again, this is t to the power 4. C again, here is t to the power 4. C again, t to the power cube. Okay. So t to the power 4, 4b square, 4b square t square. Okay, this is t to the power 4. This is here 2t into 1t, this is t cube. Okay, right. Now take a common TQ here. So this is TQ is 4AB. Okay, and take a common T square is there minus 2A T square. This is 4B square, and this is again plus 2C T square, and again the coefficient of T, that is 4AB, and this is 4AB only into T, and the constant term here is A square, and this is 2GA, and plus C is equal to 0. Okay, see carefully. Okay, right, all are right. And now you have to find the here the 4 root. Here are 4 root. That is tan theta 1 by 2. Okay, tan theta 2 by 2. Okay, tan theta 3 by 2. And also tan theta 4 by 2, as the degree of this equation is a 4. So now find that is the find here that is the sum S1. So that is the summation T1, summation tan theta 1, sorry, this is tan theta 1 by 2, and that is equal to minus B by A. This is minus B by A, like that. Okay, minus 4AB by, this is as A square plus C minus 2GA, and again S2, and this is B here. Okay, 1, 2, 3. I think this is the norm. And this is the summation of tan theta 1 by 2 into tan theta by 2 here. And this is minus, and this is a plus, this by this. Minus 2A 4B square plus 2C by here A square plus C minus 2G. And same as S3. S3 is equal to minus, this is plus, again here write minus 4AB by A square plus C minus 2GA. Okay, S4 is equal to, this is minus here, so plus this by this. So A square 2GA plus C by A square C minus 2GA. Now the formula of tan theta 1, theta 2, theta 3 and theta 4 by 2 is equal to S1 minus S3 by here 1 minus S2 plus S4, and that is equal to S1. So S1 is here minus 4AB by A square plus C minus 2GA, and S3, that is S3, this is here minus S3 is this, okay. So this is minus 4AB by A square plus C minus 2GA, and y, this is 1 minus S2 plus S4. See, this value is 0 here. Okay, but this is never 0. If you solve this equation, 1 minus S2 plus S4, this is nothing is 0, so this is 0 by something is not equal to 0 in this case, and so this is equal to 0.
So in that case, therefore, we can write here, this is tan, and if this 0, okay, from the theory equation, by 2 is equal to n pi. So now multiply by 2, then we get here implies that theta 1, theta 2, and theta 3 and theta 4 is equal to 2n pi. Okay, very good questions. Okay, see carefully. Now next point here is 9. So we have to show if it is given that the cos alpha plus cos beta plus cos gamma equal to 0 equal to sin alpha sin beta plus sin gamma. Okay, now we have to show the summation of cos 3 alpha is equal to 3 times of cos of alpha plus beta plus gamma, and sin of 3 alpha is equal to 3 times of sin alpha plus beta gamma, and this. Okay, now see the question number 9 carefully. Okay, now here is this question number 11 here, solution of 11. So this is here 9. So here cos alpha plus cos beta plus cos gamma equal to 0 is equal to sin alpha sin beta plus sin gamma. Okay, and now this questions are related with the complex number. So let us assume like a is equal to like that cos alpha plus I into sin alpha, same as b is equal to, so this is cos beta plus I into sin beta, and again c is equal to, and this is cos gamma plus I sin gamma. Okay, now if we added this a plus b plus c, we then cos alpha and cos beta and cos gamma plus I into sin alpha sin beta and sin gamma, and this is here, this is 0 and this is 0, it is given condition. So 0 plus I0 equal to 0 here. So we get here a plus b plus c equal to 0. This is the case number 1. Now question here is cos 3 alpha, so that's why now we have to show the value aq plus bq plus cq minus thrice is a, b, c. No, the factor we have a plus b plus c, and the other factor is a square, b square, and c square minus a b minus bc and minus c. Okay, and see this is a 0, so you multiply 0 into something, this whole thing is 0. So you can write here implies that aq plus bq plus cq equal to thrice a, b and c. So here which is let us assume there are a equal to b equal to c, a equal to cos alpha plus I sin beta, b equal to cos beta plus I sin beta, same as cos is equal to that. So substitute here. Okay, that is cos alpha plus I into sin alpha to the power q, and cos beta plus I into sin beta whole to the power q, same as cos beta cos gamma, this is gamma plus I into sin gamma. Okay, this is q here, and this is given that the 3 ABC. So this is here cos alpha plus I sin alpha, and cos beta plus I into sin beta, this is beta, and cos gamma plus I into sin gamma. And from the left hand side, on the left hand side here is cos of 3 alpha plus cos 3 alpha plus I sin 3 alpha. Okay, now cos 3 beta plus I into sin 3 beta, and here is cos 3 gamma plus I into sin and 3 gamma, and that is equal to 3 times of, if we multiply these two the factor, then we get their cos of alpha plus beta plus I into sin of alpha plus beta. If we again multiply the cos gamma plus I sin gamma, then we get the addition like that. Okay, this is cos of alpha plus beta plus gamma plus I into sin alpha plus beta plus gamma here. So compare with the real or imaginary part. So we can write here on the both side compare with real. So comparing both sides, then Okay, this is cos 3 alpha plus cos 3 beta plus cos 3 gamma is equal to 3 times of that. This is the real with real, compare with real with real. Okay, and the imaginary part is sin 3 alpha, sin 3 beta plus sin 3 gamma is equal to 3 times of alpha plus beta plus gamma. Okay, so question number 1 is proved. Okay, question number 1 is proved. Okay, see carefully. Again, now for the second. So now this is, I think, better understood. Okay, so it is the solution for 1. Now we have to follow the part 2 for question number part 2. This is a plus b plus c equal to 0. Needed here. So now here we have to find the value of 1 by a plus 1 by b. As we see, here is the square. So that is the cos 2 alpha. So there is a if we a plus b plus c whole to the power squares, we get here a square, b square, c square plus and twice within the bracket ab, bc, ca, ab plus bc plus ca. For that we have to find this. Actually ab plus bc plus c is equal to 0 there. Okay, now so if we take our else and then we get the numerator part be ab plus bc plus ca. So that's why we have to find this expression. Actually this be 0 here. So how can possible is this? So this is here cos alpha plus I sin alpha. Sin alpha, this is sin alpha, sorry, this is alpha to the power minus 1, okay, and cos beta plus I into sin beta to the power minus 1. See, a to the power 1 by a and a to the power minus 1, so like that, okay, and cos gamma plus I into sin gamma, this is to the power minus 1. So now write here cos of minus alpha plus I into sin of minus alpha, cos of minus beta plus I into sin of minus beta, cos of minus gamma plus I into sin of minus gamma. So that is equal to cos alpha, cos beta and cos gamma. And for the sin, take a common like sin alpha, sin beta, and here is sin gamma. This is here 0 minus I into 0. So this is B0 here. So we take a LCM AB, C. So this is BC, this is CA, and this is AB. So this is here AB plus BC plus CA equal to 0. Okay, find A plus B plus C whole square. That is A square, B square, and C square. 2AB, BC, and CA. And this is B0 here, so A square, B square plus C square. So this is B0 here, so we can write here A square plus B square C square, and this is also a 0 whole square, so this is 0. So write here cos alpha plus I sin alpha to the power 2, cos beta plus I sin beta to the power 2, cos gamma plus I sin gamma to the power 2, actually this is equal to 0. So now here cos 2 alpha I sin 2 alpha, cos 2 beta I sin 2 beta, cos 2 gamma plus I sin 2 gamma equal to 0 plus I 0. We can write here and compare with real or imaginary. So we compare with real. So cos 2 alpha, cos 2 beta, and cos 2 gamma equal to 0. So for that, cos 2 alpha can be written as cos square alpha minus sin square alpha, cos square beta minus sin square beta, cos square gamma minus sin square gamma equal to 0. So now see, this is your cos square alpha, cos square beta, cos square gamma. So that is your sin square alpha, sin square beta, and here is sin square gamma. Let us assume this is a k, same means this. Okay, if we add by k plus k, and that is k means this whole and k means this also. Okay, in place of k we have to substitute here as a cos square alpha, cos square beta, and cos square gamma. and the another KB is this sine square alpha, sine square beta, and this is a sine square gamma. So from this in plus this is 1 and plus 1 plus 1. See, this plus is 1 and this plus is 1. So, and this is with 3. So we find that 2k is equal to 3. So k is equal to 3 by 2 here. Okay. So each and every part, this equal to 3 by 2. So we have to assume that this is the k. So d is equal to k. K means this is 3 by 2. It's true here. Okay. See carefully. I think all of you are better understood. Okay, this is a very important question for your competitive exam like joint light and others competitive exam, and also the board exam for B.Sc and math honors also. This video is also related with that. Okay, now see, follow the next question, that is 8. Very interesting question also. And see, this is here 8. I know we have given x plus 1 by x equal to 2 cos pi by 7. So apply the Siddharacharya formula. So pi by 7 plus 1, and this also x, and this is here 1 equal to 0. So now x is equal to 2 cos pi by 7 plus I into, no, this is root over b square minus 4c. b square means 4 cos square pi by 7 minus 4ac by 2a, and this is here cos pi by 7, and see, this is here, if you take a common, that is cos square theta minus 1. So under root there are minus sine square, so this is here minus sine square pi by 7. So you can write here, or this is here 2, so 2 are divided. Okay, now this is, we can write here cos pi by 7 plus I into sine pi by 7 here. Okay, plus minus. So only that we have to take a single sign, then now we can easily show the for the negative sign. Now we have to show the for the, we can take both the sign also, no problem. X to the power 7 here, and that is cos pi by 7, and that is here plus minus I into sine pi by 7 here, and to the power 7. Okay, so therefore cos pi plus minus I into sine pi. So plus minus not affect this condition, so this is there only minus 1. So therefore x to the power 7 plus 1 by x to the power 7. So that will be minus 1 plus within the bracket, this is minus 1. So this is minus 2. Okay. So very good questions for that. I think very easy. Not tough, but okay, see carefully. Okay, now we have to follow the question number 7. So see, find the general solution, general values of real angle of theta. Real angle of theta. You know, if we multiply this this intense factor, then there will be the addition of all the angles. Okay, see, this is there 7, and this is there cos theta plus I sin theta, and cos 2 theta plus I sin 2 theta dot 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 dot, and this is your cos n theta plus I sin n theta. This is your n times of theta is equal to 1. Okay, and now you know the rules here, and repeat here theta, 2 theta, 3 theta like that, and this is your n theta plus I into sine of theta, 2 theta dot 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 n theta. Simply this is the AP series with natural number. If you take a common, that is here 1, 2, 3 dot dot to n. Again I sine, again repeat, and theta, I take a common here 1, 2, 3 dot dot to n, and this is 1. So cos theta n into n plus 1 by 2. Okay, plus into sine I sine n, and this is a theta, n into n plus 1 by 2 is equal to 1. So 1 you can write here. As we get the more one solution, you know, I repeat here in these cases. So for the more solution, and this is here is 0 plus I sin 0, you know,
So in case of 0, as you see the left hand side, there are more than one solution. So if we get more than solutions, we can apply the rules 2k pi. This is 2k pi plus 0 plus I sine 2k pi plus 0 here. We can apply the rules here. Okay, so therefore we can compare this theta times in into this is equal to here 2k pi 2k pi this is okay. And now this is a theta is equal to 4k pi by n into n plus 1, okay, where k means 0 1 2 3 dot 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 to n minus 1, okay. So this is the solution. This is the solution for question number 7 here, okay. Now for question number 6. More somewhere in my video there was a this type of some common problem already solved this problem, okay. Again I repeat the question number 6 here, okay, in my some video, and again repeat here, okay. Now z suffix r, and that is here cos pi by 2 to the power r, I into sin pi by 2 to the power r, okay. See here z1 z2 z3 dot 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 to infinity, we have to show this is equal to 1. So now this is here cos pi by 2 plus I into sin pi by 2, okay. Again cos pi by 2 square plus I into sin pi by 2 square. Again repeat cos pi by 2 cube plus I into sin pi by 2 cube, okay. So and this product be infinity, so angle would be a sum like that, and the series here is to infinity also, plus I into sine of that also. This is pi by 2 plus pi by 2 square plus pi by 2 cube and dot dot to infinity here. So now this is a infinite GP, and sum of the infinite GP series is a by 1 minus r. And it will be possible when the value of r is lies between minus 1 to plus 1. See here r is less than 1. So you apply the rules, that is a by 1 minus r. So a here is pi by 2. So now this is 1 minus r, this by this is half. So since r is equal to half here, so that's why I apply the rules a by 1 minus r. So see I into sine, this also pi by 2 by 1 minus half. So therefore this is here cos pi plus I into sin pi. So therefore cos pi is minus 1 and sin pi is 0. So this is minus 1 is the answer. So I think all of you better understood for this problem. Is the problem, okay? Now see carefully. Okay, now I have to solve the question number 5. Question number 5 is very easy question, and this is here cos pi by 15 plus I into sin pi by 15. This is to the power 10 here, and also there cos pi by 15 minus I into sin pi by 15 to the power 10, and whole divided by cos pi by 3 plus I into sin pi by 3 whole to the power 6 here. Okay, now apply the rules, that is cos 10 times into pi by 15. Again I repeat here I into sin 10 into pi by 15, and again cos 10 into pi by 15 here, and minus I into sin, this is sin 10 into pi by 15 here. Again cos 6 into pi by 3 plus I into sin 6 into pi by 3 here. So see, these two terms are cancelled, so remaining part are cancelled here. So this is two terms are same, so 2 into cos of that is here 5 by 5 are cancelled, so 2 pi by 3. This is 2 5 is 3 and 2, okay, and this here cos pi by 2 plus I into sin pi by 2 here, okay, sin pi by 2. So now see this cos pi by 2, okay, pi by 6 times, okay, no, I have a mistake there, okay, this is 2 times of, okay, this is 2 pi, wrong region, this is 2 pi here, okay.
Okay, see, this is 2 into cos pi minus pi by 3, and cos 2 pi on the scale of, this is 2 pi, on the scale of 2 pi by plus 0, go to the this cell of this cell, okay, makes maybe, so this is here 1, and now 2 into, and sin 2 pi is 0 here, so cos pi minus this is pi, this is pi, then this, the cell on the second order is on the sine cell, so that will be cos, this is there minus pi by 3, so this is cos 60, cos 60 is, this is 2 into minus half, so this is there minus half. Is your answer for question number 5. Now next question, see carefully, okay, boys and students, see carefully, okay. So now solve the question number 4. For question number 4, there is a solution. X to the power 7 is equal to 1, okay. You know, x is equal to 1 to the power 1 by 7, so there is a fraction that is 1 by 7. So see carefully, we don't get only x equal to 1, see carefully students. So for the fraction number that is 1 by 7, so there is a 7 solution. So in place of 1 we can write here cos 0 plus I sin 0. Again see, this is 1 by 7, so in place of more than one solution, so we can replace in the 2k pi with 0 plus 0, okay, I sin into sin 2k pi plus 0, and this is here 1 by 7, so you can write here by 7 and this is by 7. So now here is k equal to 0, 1, 2, 3, 4, 5 and 6 there, okay. This is the number of solution, okay, of this equation. If you put 0, then if you put 1, 2, 3, 4, 5, 6, 2, okay, then you get the solution of this question number 4. And for 3, for question number 3, here is a 1 plus I to the power 1 by 5 and 4 1 by 5, yes. And you see that this is also 1 by 5, so here is more than one solution. You get here, that is 1 by 5, so there is a 5 solution. Now we want to the express as a cos theta plus I sin theta pattern. No, so that's why. And it's here, this is multiple of 1 by, that is 1 by 5 there, okay. And now this is here 1 by root 2 plus I into 1 by root 2. So balance, and this is okay. Now this is here 2 to the power, this is 1 by 10, okay. And now this is cos 45 and this is cos 45, this is pi by 4 here, and I into sin pi by 4, this is sin pi by 4, okay. See, and this is 2 to the power 1 by 10 here, and now this is added with 2k pi plus pi by c. Again we repeat here, there is the fraction power, this is 1 by 5, that's why in that case, in this formation here, we get a 5 solution. So, okay, this is 1 by 5 here, so you can write 2 to the power 1 by 10, and again, and this is cos 1 by 5 into 2k pi plus, and this is there pi by 4, plus I into sin 1 by 5 into 2k pi plus, and pi by 4 here, okay, where k equal to 0, 1, 2, 3 and 4. Okay, and find the cube roots of minus 1. See, this is 2 here, so this is here x cube equal to minus 1. Again you can write x to the minus 1 whole to the power 1/3, and this is here cos pi. Cos pi means this is minus 1, so I into sin pi, this is here 1 by 3, and if x is equal to, and this is here cos 2k pi plus pi, okay, plus I into sin, this is 2k pi plus pi, this is 1/3, this is here 1/3. So if you put 0, 1 and 2, then you get the solution. If you put 0, when k equal to 0, then x is equal to, if you put 0, then pi by 3. This is a pi by 3, cos pi by 3, it means here, this is here cos pi by 3 plus I into sin pi by 3. See, this is cos 60, this is half here, and plus I into root 3 by 2. When k is equal to 1, then x is equal to
this is here 1, then here 3 pi by, this is 1, if we put here, that is 3 pi by 3, this is pi plus I into sine pi. So sine pi is 0, cos pi is minus 1. Okay, when and k is equal to 2, then x is equal to cos, if we put here 2, this is 2 to the 4 plus 1, that is 5 pi by 3. Or this is here 5 pi by 3, this is here 5 pi by 3. So this is 6 pi by 3, and that will be 2 pi minus pi by 3. So pi by 3 here. So plus I into sine 2 pi minus pi by 3. Okay, and see, this is 2 pi. This is lie on the this is 2 pi. This is lie on the cos cell. So that's why cos pi by 3. And in the cos cell the sign is negative, so minus I into sine and pi by 3. So cos pi by 3, this is cos 60, this is half, minus I into root 3 by 2. Okay, so these three solutions you know. Now last solution, and for this chapter discussion of complex number of this video. This is a very important class for all of you. So carefully, and in my channel there is a more classes, and share it carefully and see that carefully. Classes is the very important for that, and I have also posted the 4 complex number video. Okay, see, now for that you have a simplify. This is 1 sin phi plus I cos phi, and this is equal to 1 plus I, and this is sin phi minus I, this is here cos phi, and this is to the power n. Now see again, I replace that in place of 1 we can put here, this is sin square phi plus, and this is here cos square phi, and this is also sin phi plus I into cos phi, and also unchanged factor, this is don't change there. Okay, this is cos phi, this is to the power n here. Okay, now again repeat, this is as a cos sin square phi, see here, this is sin square phi by sin phi, sorry, sin phi plus I cos phi. So in that case, this is sin square phi, and this is I square, and this is cos square phi, so it is a plus cos square. So see, sin phi plus I into cos phi. Okay, 1 plus sin phi minus I cos phi, and this is to the power n. And see again, factorize this, so take a common in between them. So sin phi, take a common, sin phi plus I into cos phi. So other factor we have, this is sin phi minus I cos phi. Okay, and this take a common of that. Okay, so there is left is 1 here, and now on the denominator part we have 1 plus sin phi minus I cos phi. Okay, see, these two factors are same, so these are cancelled, and this is to the power n. So you can write here sin phi plus I cos phi and to the power n here, and from the middle part, and we can write here like we can use the rules of Newton's law is what we are first and we are cos. That's why it can be written as 90 minus theta, and also this is sin pi by 2 minus phi, and this is also a minus. Okay, and this is to the power n here, so we apply the rules here, multiply in this position n into pi by 2 minus phi here, plus I into sin n into pi by 2 minus phi, and then multiply by n, this is n pi by 2 minus n phi, and I into sin n pi by 2 minus n phi. So this is the important video for yours. Okay, see carefully. Bye everybody.